Hello, everyone. My name is Sarah again. So I'm going to be teaching the Python course. This is week 4 for all of you guys who have been attending our last one. So thank you for joining us. I'm going to quickly share my screen. 1 second. And then I'm going to go to our presentation. All right. Can you all see my presentation and hear me all right? I just want to make sure that everything's working and is clear and that you see the screen here. Yeah, you should. Okay, awesome. Again, welcome to Python Lesson 5. So this is week 5 of the Code Arena Lifelong Learning. And again, we're working in Python in terms of data science. And again, welcome to class. We're kind of coming towards the end. And so we're going to move again more into just coding and working together on a coding project. So today we're just going to start with a quick review of the code that we covered last week. And then we're going to work on visualizing results and further analysis. So we're going to take these both and kind of work on them in depth today. And again, that's kind of it. We'll go as far as we can, and we'll kind of finish up next week on whatever we need to. So quick review is that if you remember, we worked on pandas and data frames. So we created our own data frame. I'll quickly go to the code. If you remember, of the Olympics data, we read in different types of years in sports. So we did some data cleaning. If you remember, we dropped a lot of duplicate values and also removed a bunch of columns that we did not want to use. We then also did, so again, data cleaning, the data frames, and then also basic analysis. So I'm going to switch quickly back to the code. And if you remember correctly, we started pulling the data from just the first year and the last year of the Olympics. So if you remember, our data set was like a bunch of different columns, but it was based on the Olympics over the years. And we are hoping to compare the amount of sports over the years from 1976 to 2008. That is about 9 Olympics that happened during that period. And we want to look at how those different columns, or not the columns, but like the columns that contain the sports for each of those years changed. So if you remember, our first year, which was sports 1976, we found out that there were 21 sports. And then in 2008, we found that there were 28. So if you remember over the course of these, the first and the last year of our data set, we added 7 different sports to the Olympics. And so today we're going to be again working on visualization. So as I remember, we have this quick change of 7 sports, and I'm going to go to my code quickly. And if you go, I'm going to show you this just a little quickly. But if you look at this little plot right here, we're going to actually be making this plot, by the way. But this blue line is the change of sports over those years. So this is 1976, this is 0. And then 8 is that 2008. If you remember, 1976, there are 21 sports. In 2008, there were 28. Now, there are 2 things that we're going to be working on, learning a little bit about projected growth versus actual growth. So this blue line here is the projected growth. All we did was take the first and the last point and plotted them in a line to see if every year was equal, how many sports were added. And it was like half a sport, mathematically speaking, was added every single year in order to achieve this 28. But we know that's not true. That's not how sports work. You have a whole sport, and you don't always add one every year. So this purple line, which we're also going to be making today, is the actual growth versus the projected growth, which is the blue one. So again, this is just what we covered last week for all of you guys who attended. So we're going to be learning how to make that today, by the way. So I'll show you how we did that, and then we're going to work on it together so you can make your own graph. But so this was what we accomplished last week. We fed in our data through a CSV file. We then took only the year and the sport columns. Then we had all those duplicate values, if you remember, that were repeating variables. So we removed those. And then we took only the year that was from 1976. And then we took only the year that was from 2008. And together we added those and then saw how many were added over that period of time. which was the 28 in the end, which was 7 that was added on from 1976. So again, a visualization today, which is what we'll be working on, is the projected progression versus the actual progression. And so again, we're just going to get right into the coding. We're going to be working in Jupyter Notebook, an IDE environment. And so by doing that, there's not going to be many slides. It's just more going to be talking and coding together. So yes, this is where I move over and we're going to start coding. So today, you're going to write all of this code together, and I'm going to help you start. So as you can see, this line here is where, of this hashtags, is where we stopped pretty much yesterday. So everything below is stuff that we're going to make together. And it looks a little complicated, I know. And there's a lot of different lines of code, but it's very easy. So the first thing I did to simplify it, because there are more advanced ways to do it that we're actually going to try out next week, but I got the information for not just the first and the last year, but every single year. So the way you would do this, and we're going to build one, and then you copy and paste it into the next one. So we're going to create our first variable, which is sports. Again, I'm just going to type it out too again, so you can watch me type as well. Sports 1976 equals clean data, followed by brackets and clean data inside, followed by another set of brackets where we put year equals 1976. You can use a Python IDLE for this environment. It works exactly the same. If you have the file already read in, which we did in the last week, then you'll be able to completely do it in any type of coding environment. I use Jupyter Notebook because that's kind of what we learned in the beginning, and it's a really nice tool for this type of work, but you can really use any type of environment. So if you look here, this code right here that we just wrote, which I'm just going to show you up here, is creating a variable called sports 1976. And to that variable, we are assigning the column of year in clean data that equals 1976. So it's going to go through our data set, find all the columns where the year is 1976, and create sports 1976 from that. So I'm going to print that quickly. And I'm actually going to take this for now. I copy it to the things, so we don't worry about it. We're going to print this. Oh, forgot to import. So whenever you want to rerun your code, just as a little reminder, because I didn't do it, is you always want to start at the first cell, so the first block. So for those of you who were coding with us last time, you want to go ahead and run everything from the top. So now that that's run, you see there's a little asterisk, and then it changes to a 2. And now this ran. So I just printed sports 1976 right here, which is this first code that we wrote. And as you can see, it lists all the sports that we had for that first year of the Olympics. So we had wrestling, weightlifting, volleyball, shooting, sailing, rowing, pentathlon, judo, hockey, handball, gymnastics, football, fencing, equestrian, cycling, kayaking, boxing, basketball, athletics, archery, aquatics. So these are the different rows that we have, and the different sports that's included. So the next thing we want to do is find the length of these sports, right? How many sports are in here? So we create another variable. This variable is going to be called number 1976, and it is the length of sports 1976. So it's going to take the length of this, how many different rows there are, so how many sports there are, and store it in this variable number 1976. So now if I print number 1976, it just gives me 21. So that's how you make just one variable. We're going to do this for all 9. So if you were able to get your first year of information, which we did already kind of do, if you have that written out, go ahead and let me know. I'm going to keep moving forward, but you're more than welcome. I want to kind of see who's gotten this so far. And feel free to stop and ask questions at any point. So now we're going to do it for the second line, which is get the second year. And you don't necessarily have to type out these comments. They're just for me to be able to explain it a little better. And so what I did up here is I highlighted the code I wrote and I copied it and then I pasted it down here. So now all I can do is go and change the year. And the Olympics occur every 4 years normally. So in the case of all our data points, you just want to add 4 to it. So 1976 turns into 1980. So you just go through, you change number and the variable. So as you can see here, I now have sports 1980. You can go ahead and code if you want as we go along. I can also more than happy to pause at some points, just like if you guys want to code on your own. So just let me know if you want me to pause at any point so you can catch up or follow along. But so let me show you just one more, and then I'll go ahead and code the rest, and you can pretty much follow along with that. So in this case, I have sports 180 now, and it's now taking the years that equal 1980. And based on that, it now takes the length of this variable and stores it into 1980. So may I ask, what are you struggling with understanding in the code? Like is there any point that I can help you maybe understand a little better? Also, so yeah, if you want to, you can just go ahead and add these all in. And every year, just want to add 4 from the last one, because we're changing both the variable and the data that it pulls from. Yes, this is continuing from the project that we worked on last week. So if you remember, we got to a certain point where I'll go back quickly. Yeah, here it is, where we did all this last week. And yes, if you watch the last video, it will help you. So we read in the file, we chose the sports. And if you remember, we compared the first and the last year's sports. We're now going to go back and compare all the years of sports. So if I go back quickly to this graph, last week we found the first and last year. We projected what that growth would be. Now we're going to find how it really grew. So we're going to look at that next. So as I have here, we now have our 3rd year. I need to change this. And so we're just going to go and copy and paste this all on. So we got to collect it every year. So this is 92. So again, it's just 4 incrementals. So if you go to the video that we had before, we have a link in it of where you can download the data. And so then you can go into the CSV file. And so it has the instructions in our last video of how to best download that. All right, so we're gonna, again, we are on 1996. So we have just a couple more to do. Actually, I can copy and paste again. So now this is where we hit the 2000 point. Make sure that you have 3 zeros after year 2 and not 2, because otherwise it will get confused, because we do not have a year 200. And that was an error I made earlier, actually, because it's hard to sometimes realize how many zeros. Yeah, and so you do want to download it as a CSV file. We have some more information, again, that you can see. Yeah, there's a website, and so there's a link within that video of last week where you can go, and if you've not read in the file yet, you can get the data to download. And it's open, it's public, and it's easy to get to. And once you get there, you're able to download the data pretty easily. So we're now almost finished up, and then we'll take a quick moment to make sure that everyone has gotten their 9 years of data, or 9 points in. So what's interesting too is this year we actually do not have the Olympics. So the Olympics are being moved to next year, which means for the Summer Olympics that this will be one of the first few years that it will be actually 5 years in between. I can see if I can grab the website link, but it's in the beginning of our last video. So if you go there, you'll be able to find it really quickly. But so if everyone was able to get this written, let me see if I can get it. It was in the past video. But so what I'm going to go ahead and do is if you guys can go ahead and write this code out again, please do so. And let me see if I can get that code for you. I will get that link if I can quickly, just so you guys have it. But we did cover that in our last lesson too, if you guys want to look at some point. Let me see. Yeah, so I'm going to type in, but I'm just going to mention that the one letter is an I. So if you watch the video, you'll see this, but let me just type it out. So. It's a lowercase L, actually. So let me, thank you. Codarina got it in. Let's make sure. Yep, that is the data set. Thank you. I was looking for it and I was almost there. But okay, so now that you have that, let me share my screen again. So again, if you watch our last video, we'll have more information on the best way to do that. But so if you do have this, we're going to go ahead and use this. But now, as you can see, we have all the sports years saved. So we have the 9th year, the 8th year, the 7th year, 6th year, 5th, and so on in these variables. We have both the length and the names that were acquired from doing this. So if you have, is anyone at this point yet? Or is someone still working on it? If you could just communicate with me and let me know. That way we can either pause quickly or we can move right along. I want to make sure everyone's kind of getting it who can right now, for those of you who do have the data from last week. But again, once we get these, we're going to compile them together so we can get the numbers to do the next work. So the next part we're going to do is, so again, I'd written this here, but it's the same exact line of code. Take the number total. So the number total is going to be a combination of all the above. So what we're going to do here is you have number total, and then we're going to store number 2008, number 2004. You're just going to go ahead and type the numbers in. So you can just copy and paste them and then change one of the digits. So just a review of what we've done so far is, if you remember, we read in the data set. It was this huge, big piece of data, and it was really hard to work with. So we just took out the 2 columns that we wanted, which were year and sport. We did it. So the graph is not going to run just yet. We got to build that next. So we are setting up now our analysis for the graph, so to be able to create and visualize our results. So we pulled the first 2 data columns out, which were sports and years. And then we also went here, created a new data set where we dropped all the duplicate values. So we just did one last step of cleaning. Then we went through, which we just did now, and we stored all the values from each year. So what we did here, again, is we have both the length and the name of the sports. So I can see if I can quickly show you that data set one more time so you can kind of review what we've done before we start the analysis. So this is what we started off with as a data set. We pulled just the columns year and sport. So we got rid of all the other data. We just focused on these two right here. So after we focused on these two, you see that we have all these repeating values between just these two different columns. So we've removed all of those next. But now we still have all the sports from 1976, which if I go and I print that, it's going to give me all the sports right here that we had in 1976. Now I can go do that for this too. Print sports 2008. So remember, if it grabbed the sports that are from 2008, and there are a lot more. So as you can see, we've spent extra sports in comparison to 1976. That was something we did last week, and now we're just doing it with more years. So when we write this code, this first line here goes to our data set and grabs all the sports where the year is 1976. Oop. And then we go and we do that for 1980. So then we go, it's not going to show me because there's so many, but then you try to go to 1980. And then if you go to, yes, you know, it cuts off here because there's so much. But if you would go to 1980 and you would find all the sports links for that. So again, we're just doing this for every single different year. And now we're going to combine this together. So all those names of those sports and years. And we're going to do it with num total. So we have to combine these to be able to plot them because the lengths are all different, but we want to write them sequentially. So this line here is called num total. Num total is a variable. It's going to be a list, and it holds the length of the number of sports in 2008 and so on. So every year, the amount of sports that they had is stored in a different number. So I'm going to go here and I'll print num total to show you. Just making sure. And then I hit run. And look, so here's our list where it shows you for each year what the sports are. So now that you take those, and we are going to be plotting, so we're going to plot the X and Y axis using code in a hot second. So as you can see, these would be our Y values. So if we look back at our graph that we're going to make, these are the number of sports over the years, the amount of sports added. So we need the number, the actual number, which this is what it's going to be. Then we're going to have the year periods, so the year 0. Ooh. I don't know what that did. 1 second. I don't know why that went blue. That was funny. All right. So what we did here, though, is we collected those again. I'm going to print that, make sure that works. And we're now going to redo our plot. So what we're going to be doing, because I'm not sure why it's showing up this way, is I'm going to actually remove this because we need to now look at our graph. We're actually going to make our graph right now. And we're going to start with plt.plot. So now the first thing we're going to plot is just the total. So right now, just the length overall of first year versus last year. So if you remember, actually we'll start with the progressive. So this is how you code, is you want to go back up here. And if you want to code a graph, you start with importing matplotlib.pyplot as PLT. So this is a long line. If you remember, we use pandas to read in our data. It's very similar to pandas, but it's used for making graphs. So what you want to do is you want to import it as this. So matplotlib.pyplot as PLT. So now whenever we use it, it's going to be signified by PLT. That's how we let the code know that we want to use this package, which we covered a little bit in our last lesson and the lesson before that. So once you've imported matplotlib.pyplot, which is a long way, which is why it's just PLT plot, you can add in your data. So here you have your X and Y variables. In this case, X is just going to be what X is, and we're just going to put in num total and see if that works. So now we actually have, if you see, our graph. But what's wrong with this graph? Can you tell? Are you able to see what you think might be wrong with this? If we are trying to graph the number of sports over the years, there's something that kind of looks wrong. If this is supposed to be the first year, this is supposed to be the second year, this is supposed to be a third year, and so on. Besides there not being a y-axis, which we kind of have the numbers here, what is off? And in this case, it's the code is going downwards. So instead of increasing, what happens, the sport should go from 21 to 28. Our list is reversed. So how do we fix that? We could go back and we could change these lines. We could flip it. But that's a lot of work to go and change every single variable now that we've made it. So what you can do, and this is just to bring you back a little review. Do you remember this? These are the list methods. We learned this in week 1. So these are different functions that you can use in order to change lists. And our friend right here, number total, which has all the sport numbers, is list. So if you ever want to check to see what something is, you can type, and it's a function that's going to return what type of variable it is. So I'm going to print this. And it tells me, okay, yeah, it is a list. So what I'm going to do here, just as a quick little fun thing to remind you about lists, is num total dot, in this case, one of these methods. So if anyone thinks of which one can switch it or flip it, go ahead and let me know. But I think we're going to try reverse. If you use reverse, see, and then I'm going to put just parentheses there. Now if I run that, and then I print num total, let's see what works. And as you see, it's now increasing. We start with 21 and move forward. So let's go back to our plot. We're going to do more things to this plot, make it more fun. This is just the starter plot. So we're going to run this. And as you can see, it's now flipped. So you just use reverse to fix it and put it in this increasing order. And now it's ascending. So this is the growth over the entire year. So this is actually how many sports were added. So as you can see, we had 21 sports for the first 3 years because you start counting at 0. We then increased to about 25 sports year 4. So that was kind of linear growth because we added 1 in year 3 and 1 in year 4. And then we kind of added 1 in year 5. It kind of grew a little differently. Then it grew a little more. And then it stopped. We had sports in 6 really added. So one of the ways we can change this, yeah, so now it's an increasing order, is we can also add color. So one way to add color is by doing 2 different things. You can do a color picker, or you can just type red. So like color equals red. And that should work and it changes the line to red. But if you want to have some more fun, you can make it another color by using hex color picker. So if you want to, go ahead and Google hex color picker, and you're going to get this little cool tool here. You can move this circle around, choose different colors, move this around, and choose a color that you like. So if you're following along right now, go ahead and find a nice color that you like, and we're going to actually change our graph to one of those colors. So now we have, I'm going to choose this bright magenta because I like magenta type colors. And do you see all these numbers at the bottom? You want to go to this one right here. So the one that says hex, the hex code. Oh, you want to pick that color. Go back. So what you want to do is, as you can see, you can highlight that, or you can just copy it and type it back out. But I'm going to copy, and then I'm going to go back to my code. And you don't copy equal more. You just put quotations, and then you put it in. So now when I run this part, my line is that exact same purple as here. So that's a fun trick if you want to choose an exact color. So you can choose literally any color. So like I'll go back and I'm going to choose this one. It's deep purple. And I just change it and run it. Now it's a it's hard to tell, but it's like a purple. So now we have the the actual growth on here, but we need to get the projected growth. So now we're going to try to add a line to our plot. Do you know how to add a line to a plot? What do you think we're going to do? Do you think we're going to add it to the plt.plot, or should we just make a whole nother function and add it right below? Well, the truth is we're going to actually be adding another one. So you don't have to do much, just this, and then add it in. However, we don't have the data yet on just the first 2 years. So what we need to do is we need to create another variable called number projected. And number projected equals just the length of 1976 and the length of 2008, because it's what we did last time. So put it here, and I'll just let it choose a random color right now. I don't really care too much yet. Oops, I forgot to run this. So you want to run your first code ahead so that it actually assigns this variable. Because then you go here and they graph it. Now, what's one of the issues is our line right now. Oh, the name of the color picker is hex color. So you literally just Google. You could even Google color picker and it comes up. So this is just going to allow you to choose any type of color that you like. And then you can go and you can copy the hex and put it in. So it's a really nice, so it's kind of fun to play with. This is kind of where coding gets more artistic, and you can kind of play around with what you want to see or show. There's all different types of graphs you can make. Today we're just kind of focusing on a string graph because it's the easiest to make when it looks like the little line or string is what it's sometimes called in Python. But as you can see here, we created number projected. But one of the issues is number projected only has 2 variables, and we have no assigned x values. So instead of being able to follow this line and know that this last one is 8, the coordinates are such that the coordinates for number projected, these 2 variables, is going to be 21 or 0, 21, and then we're going to have 1, 28. Which isn't true, right? We want to change this. This isn't code. I'm just showing you how it should look. Is right now, that's what this graph is, this blue line. But instead, we want it to be 8 to 28. We want it to extend out, right? Because they end at the same time. So one of the ways we're going to do that is we're going to create something called years quickly. And years is just equal to 0 and 8. Because then what we're going to do, this is our y. We're going to put year as our x. So again, this is the x coordinate and this is the y. In this case, we're using a data set. So in our first plot, it doesn't matter. It will graph itself. But now when I run it, oh, I forgot to run this first. You always want to define your code. See how it looks? So look at this graph right here. You just built that. This is exactly what we started off with. So what we can see here is, if you remembered, we talked about something called projected growth versus actual growth. The projected growth would be taking 1 and 2 years and comparing it over the course of a time. The actual growth would be what statistically it is actually equal to and not estimated. Yeah, so this is kind of our first graph. So let's go ahead and change the color of this second line, because I'm not a big fan of this blue line. So go ahead and pick a second color for your second line if you'd like. Remember, you just go and you copy the hex code. You move over, we're going to type it. And I'm going to check again. And now I have gold and purple. One of the other things you can do is, so now you can add, so if you're following along, you see that we can add also labels to our code. So by using plt.ylabel and plt.xlabel, we can add the names. Oh, I think my screen sharing stopped. 1 second. Oh, I'm sorry. I don't know how long that's been off. But so you can go to plt.xplot, or x, sorry, label. And you can name it like years. Then I'm going to put 1976 to 2008. So now I can run that, and it should add at the bottom of our graph. If you see, we have years, and then it's 1976, which is here, to 2008. What should we call our Y label? I'll let you guys pick our Y label if you'd like. And again, you can change these to whatever you'd like yourself too. They don't have to be exactly what we're putting them out as on this actual graph. So I just want to see for you, those of you who are coding, is anyone having any questions or trouble that they'd like to go through? But yeah, so the color picker is really cool. So I'm going to change one of mine while I wait to see if anyone's got some quick questions, because I do want to check in. And if there's anything that you are that seems like it was covered before, you're more than welcome to go back to the last video, and I'll hopefully explain a bit more. Numerics, yeah, we could do numerics, like number of years type thing. I mean, number of sports. I like numerics, so let me spell that out. Yeah, so let's run it and see. We added, so like I put numerics, or I can do number of sports. And now number of sports is there. Number of activities, that's a good one. So let's quickly change it. We'll do number of activities. I can spell activities. All right, there we go. And see number of activities. So you can change both of the labels to include this. Now, what do you think is something that'd be great to add to our graph? Is there, as a data scientist, or even just a graph person, like, do you just like doing this for fun? As a coder, it's always good to look and see where can we improve? What could we add to this to make it better? How can we make our graph or our code more efficient? What could we do to make this, I don't know, better? Could we maybe graph more things? Could we include the number of sports? So like, you know, here you can't really tell that, like here actually you can't tell it's 21 because it doesn't change. But like 4, you kind of got to guess where it's supposed to actually hit. Is there anything that we should add to make this better, do you think? Lines to make it real graph. Good idea. Does anyone else have any? All right, so why don't we start trying to add lines? I'm going to go here. I'm going to type in plt.grid. If I'm correct, I should do it. Yeah, so as you can see, we now have grid lines in our graph. So if anyone has anything else to add, we can start talking about it and looking at it. But so in this case, as you can see, we have plt.grid, and then we have line style, which is we want it to be a dash. I think you can change it to other things too. Let's try a plus. Yeah, no. That did not work. We have to make it a dash. You can also change the line width. So right now ours is a little big. So I'm going to make it half that size. We're going to make it 0.25. And then the color's red. I don't know how I feel about the red, y'all. I'm thinking we're going to kind of change that. So I'm going to go back to my hex color picker because I kind of want, I think, a dark blue, like a lightish, darkish blue. Oh, this green's not bad. So as you can see, I'm picking my hex color. That's my, oh, sorry. Let's try this. I don't know why it keeps stopping. All right, so this is what our grid looks like now. So we can add grid lines using the plt.grid followed by line style, line width, and color. So I think can you see it now? It says it's screen sharing now. I didn't realize this went off. I think I hit the hide button. You should be able to see it now. I'll wait because I don't want to talk more and find out you can't see it. Okay, it's okay now? Awesome. I apologize for that again, sincerely, and thank you for letting me know. So again, this is what our cool graph looks like now with our grid lines added on. So this is what we can do. Again, matplotlib, which is the package, has a lot of different options. And if you want to customize this on your own after we're done, you can literally go and search matplotlib, or pltplot is usually easier, and then you can put color, or in this case, legend, and then you can search up. There's all different types of documentation. So like here, go to this one. They tell you how to add stuff on. So feel free to use any type of these resources that will help you allow you to create more things. So like again, legend, and then you put the labels. So again, set label, and then you make a legend. So there's all different ways to do this. But again, let's go back to our grid. So this grid is made out of dashes right now. The line width started off, and I'll show you, it was 5, and this is the color. So it's very thick, it's very bold, and you have this bright red. But in reality, again, this goes back to how can we make this better? The red is a little kind of bold, and it's almost hard to see the lines over it. So now what we want to do is we probably want to take this grid and make it a lighter color. We want to be able to see it, but we want it to be less. So I'm through, I'm going to pick this light green, and we'll see how this works. So I'm going to go here and add this color, and let's see. Oh, I might have to do color equals. And as you can see, I still have my grid now. It's still there, but it's a lot lighter. It's easier to see the actual lines. It's actually so much better. And so part of that is changing things like that. So now we can look, and I can think of maybe one other thing that we should maybe add. What do you think it should be? I'm wondering, and I'll save this one, and then if anyone has anything to add, go ahead. But I feel like it's a little difficult to know which line is which. We coded this, so we know that this gold line is the projected growth. We know this purple line is the actual growth. But the truth is we can't tell someone that. What if we wanted to share this graph all around and we didn't have all the time to explain everything we did? We want to sometimes add things like legends or labels. So what I'm going to do for this one again is I'm going to show you how to find answers on your own. Because again, part of getting the coding is not always having someone there to help you, or not learning through a lecture or even a class, but on your own. So we're going to start with this, just the idea of the legend. And I'll guide you through the whole process of finding good answers and trying them out. So yeah, points at the intersecting lines is a good idea too, by the way. But so we're going to start with the legend, and then we'll try that maybe next, because having that key is going to allow us to be able to share this better and more effectively. So what we're going to do is, normally if you want to figure something out, Google's your best friend. So what I'm on now is the actual matplotlib legend. So this is what's going to tell you actually. This is actually written by the company that made this package. So there are two different ways you can find sources. One is like through forums or Googling information that comes from people who may not be necessarily the people who did it, but are great coders. So you have resources for that. But then you also have resources that come from the companies themselves. Those are usually the best. I would highly suggest using those. And so again, we're at Matplotlib right now. You can actually download it from there. So what we're going to go here, and you can see that they have some labels they've created. So we're going to read through their code and then see if they have results, which they don't always do. So as you can see here, we don't have it. So what we're going to do is read through, and here we're going to see labeling existing plot elements. This kind of sounds like what we want. So if we have a plot of 1, 2, 3, it's just legend here. Now the axis for what they name their plot, we just put PLT. So let's copy this. Part of it is we're going to go down. And we're going to add this to our whole little plot thing. We don't want the ax, we want PLT because that's what we're using, legend, and we're going to put test in here. And it's always good that when you're changing things or trying something new to only change like one thing at a time. You don't want to run a bunch of things because then it gets confused. And if you're trying to solve an issue and it doesn't solve that issue, it can be difficult to know what worked and what didn't. So I ran it, and now look. So where the purple line is, it now says test. But the purple line is not test, right? It's going to be projected growth. Or no, the actual growth is the purple. So I'm going to type actual growth here, and I want to move this. So I'm going to Command X. I'm going to move it up to this part. I actually spelled actual wrong. Let's run it. It's there. Now it says actual growth. Look at you guys. You got this amazing graph going. So now we're going to go, and we're going to go down to this one, which is the projected number. Another one. And we want to put projected growth, I believe. And again, this may not work. This is something that we're trying together, let you understand how to follow along. As you can see, I messed something up. What did I get wrong? It looks like a bug issue. We're going to see, because it looks like I'm a little confused actually what's wrong. So again, coding is all about debugging, figuring out what happened. And as you can see here, what's my issue? I have 2 quotations. Now, if I run that, we just still have projected growth because it only changed that one. We got to find out how to add several. So we're going to try this. Adding them together. And that. And as you can see, it has them, but they're switched. So what we're going to do is, because it chooses the first one and puts that as whatever it is, and these are off. Because remember, the first thing that we grafted was the actual. And then we graphed the projected. So our graph is switched. So I'll quickly switch it. And here we go. So if you run this now, we have a line that shows the purple part is our actual growth, and the gold is our projected growth. And so the ability to take these both is, as you can see, we still have our intersecting points, but now we have our grid, which shows you kind of where numbers are. So now when you look for 4, you can compare it better. So 4 on our projected growth would fall somewhere between 24 and 25. It looks about 24.5. What our actual growth, the amount of sports we actually had, was just 25. Here we had 26. And then we moved all the way up to 28. So we went from 2 sports in a year and then stuck. So it's much easier to be able to read those types of lines. And we also have our projected growth now. So what you can do with this again is you can go, and if you remember, for those of you who went, we took year in sport. We can change that, and we can go and take things like discipline, or even the genders of sports. How many people who compete in each sport? Countries, which countries for each year? How many countries did they choose? So again, like we could probably do this right now if you wanted to. just quickly grab the discipline column, and then let's see if this works. And everything else should be the same. Obviously, the names won't be great, but let's see if it works. Pull this first. This. And look, all we did was change the column. So everything we did worked right. Obviously, it still says sport, not discipline, but we did the discipline. We moved it, and this shows you the projected and actual growth of discipline. So that column includes things like diving, swimming within aquatics. So it's like a subcategory of sports. So there's a lot more. You have athletics. So for instance, if we go just for fun, and I'm going to print the number of disciplines in 2000. Just choosing a random year here. And if I run that, it's going to give me 40. So we have 40 disciplines, which is more than any sport we've ever had. So it's just a great example of how you can change this now that you've learned the basics. You can go and grab another data set and read in any type of data file and go and set it up. So now look at this one. We have the projected growth is actually kind of very close to the actual growth. It's very similar now. But we went from literally having less than 28 disciplines to skyrocketing to 40 and above. And that's a line that's still growing if you look at it in comparison. You could go, and this one would be hard because it's not numerical. You could choose the unique values of cities, of countries that competed. So you could actually do country versus sport. How many did we see the increase of sports? So for instance, let's take United States. Let's say United States, how many sports did they compete in 1976? And how many sports did they compete in 2008? And what we might be working on tomorrow is all three values of, not tomorrow, sorry, next week, the country, the medal, and the sport. So how many medals did the United States or the Soviet Union or Italy or Canada or any of these countries win in a specific year? And we can look at the graphs of that, or just bar graphs. We can try to make something else. So you can go and again, look up bar graphs. And again, this is about the part of learning how to work on your own so that you can go from this class and go create your own projects. You can go now, we can read, you can actually make something like this. So this is programming language use based on the different language. Actually create something that does countries. So how many medals does a certain country have? How many times have they competed? And so the ability to just take this raw data and convert it is something that we're able to do today. So again, here's our graph now of disciplines. But if I go back and I just change it to sport, and messed something up. Oh, I added a comma. I run this now. We're back at what we made the first time. But so again, that's pretty much, oops, it's not my presentation, neither is that. Here we go. So again, that's just what we covered for today. We finished up our first reel, if you remember, what's it called? Analysis. So we were able to look at the projected growth and the actual growth. And if you want, you can go ahead and take this file, you can screenshot it and save it because you made it. Like, this is really cool actually. And you can share it and add it on as a project that you've done. And you can go on and build on it. Maybe you add a third line of not just projected and actual growth, but estimated growth or something that you guessed it would be. And so you can have a lot of fun with this now. And so again, if you have any questions or comments right now, go ahead and let me know because we're kind of going to wrap up for today. And so far, it looks like there's none. Again, these videos are shared. So if you weren't totally sure what was going on today, that's totally okay. We have the videos from last week and before uploaded. So you can definitely go back and watch it. And again, hopefully that will help make sure that this made a little more sense if you weren't totally sure what was going on. So thank you very much, by the way. Again, we'll have one more week and we'll be able to focus on something else. But take this time to also, if you want to, if you're very interested, go and find an own project you want to do. If you have another data set that you're interested in, go and find it. If it's just maybe you did a survey and you have information about your friends and how many pets they have or something, you can go and work with that and create your own cool projects too, all on your own. And it's really fun too, because again, this is where the creativity comes in play, because you literally can do whatever you want, any project. So yeah, again, that's just for today. Hopefully you learned enough basics that we'll be able to go on, but you pretty much can do much on your own now from this. So again, I really appreciate you guys listening in today. I know that some of you haven't seen our past lessons, and that can be a little confusing and difficult to understand. So I appreciate you sticking through. I'm glad I'm making coding fun, by the way, because it is a fun thing if it is. I mean, like, it just has to be, I think, a fun experience that allows the freedom. So I'm glad that you guys are enjoying it. All right. And again, that's all I have for today. So just that quick question, that insert the file into the code. Again, we'll have more in depth of the last lesson, so it's going to be much more helpful than me just talking. But we do have this quick piece of code right here. So using pandas, you read in the CSV, but that video will give you a lot more information. All right. Okay. Yeah, so I hope that helps. And again, our last week's video is up on the Code Arena YouTube thing. And bye, and thank you again. Yes, bye. I hope you guys have fun in your next